Hello, my name is Ron Harris. Today, I would like to share with you some vital lessons my research team and I have learned through conducting what we call full spectrum risk reduction experiments, mostly in Indonesia. These experiments help fill a gap for humanitarian geoscience, which is supported by Geoscientists Without Borders. And much of what I will present would not have happened without the support and encouragement of GWB. We characterize our work with the metaphor of building bridges over troubled waters. The most troubled waters are in the continent collision corridor, or CCC, of South Asia and Indonesia. Although this area represents only 12% of Earth's landmass, the natural hazards in this region account for 85% of the Earth's fatalities. The way we really should look at the world when considering how to reduce losses in nature is this map, which is scaled to show natural disasters per country. The CCC obviously needs the most help by far to reverse the growing trend of mass graves. I've been working in the CCC for over 30 years, collecting data from a wide variety of sources to formulate forecasts of who is most at risk. Some of these methods involve compiling and translating historical accounts of past geophysical events, prospecting for geological evidence of large tsunamis and earthquakes, and evaluating who is most at risk from ground shaking by making our own tiny little earthquakes and using geophones to collect the data so we truly are listening to the earth. The premise I have worked under is that the technical aspects of assessing risk or listening to earth was my responsibility as a scientist, and that somehow the hazard risk information and what to do about it would trickle down to those in harm's way. For example, we identified two major seismic gaps along the Sunda subduction zone of Indonesia that had accumulated enough elastic strain energy to cause megathrust earthquakes. These data allowed us to publish forecasts in 2002 about eventual megathrust earthquakes, which would happen in the future. 2 years after we published our forecast, it happened. The press somehow found out about our forecast and converged on my office. And the story that they were trying to sell is that a geologist had predicted the earthquake, but no one listened. But that was not the case at all. The people were totally caught off guard. They had no idea about what a tsunami was or how to respond. It was not them, but it was us that failed. I knew perhaps as well as anyone what was going to happen, but I didn't deliver the warning to the last mile, those who were actually in harm's way. I gave us A minus on risk assessment, but we totally failed the communication and risk reduction. Since the 2004 disaster, we have constructed a series of numerical models that simulate megathrust earthquakes in Java, in the Java seismic gap, which is still waiting to have its megathrust earthquakes. This is a movie of the tsunami model that we constructed for Bali, which is the most populated area. It has over 600,000 people inhabiting the inundation zone, and that's not including the many tourists that flock to this area, which could add at least another 600,000 at any point. First tsunami waves arrive around 20 minutes after the earthquake, and they reach heights of about 20 meters in most places. We use the numerical model data to construct this series of tsunami hazard maps for the Java tsunami gap. The most quote unquote primitive peoples of all those affected by the 2004 earthquake and tsunami were the sea gypsies of the offshore islands. Amazingly, they suffered the least casualties per capita. Their successful response to the hazard was due mostly to their generational stories of a monster called Laboon, the wave that eats people. According to this myth, the ground shakes when Laboon is coming. And even though they had the science wrong about what a tsunami is and had no risk assessment, they had developed community response efficacy that saved their lives. They used natural warning signs and they self-evacuated. The world had to learn the hard way that it requires more than just risk assessment to save lives. And our job does not end with a risk assessment. It actually starts there. It requires us to close the communication gap. It includes community-led plans, questionnaire surveys, social media campaigns, and the practice and evaluation of risk reduction strategies. These steps are proactive because they focus on preparedness, which is much less expensive in lives and infrastructure than the reactive approach of waiting for something to happen and sending billions of dollars in to provide relief. But no matter how much is spent after the disaster, lives have been lost. This is where GWB comes in. They provide essential funds for integrating the full spectrum of natural disaster mitigation activities, not just assessing risk, but providing support for helping people listen to the earth. The projects that GWB funds encourage experiments in building resilience and developing response efficacy. So thank you so much, GWB. With the help of GWB, we've spearheaded hundreds of meetings with students and community leaders in the highest risk areas. And we ask questions through surveys and Q&A and listen to concerns and ideas, and then plan and implement risk reduction activities. One of the recommendations made by another Indonesian student is what he called ARC, which is Art for Resilient Communities, where a diverse group from different sectors of society come together to build a diorama of their community and its hazards. To help emphasize the importance of self-evacuation, we have condensed the crucial parts of tsunami survival into 3 numbers, 20, 20, 20. It works this way. In coastal regions, if you feel an earthquake that lasts for at least 20 seconds, it could have directly or indirectly caused a tsunami. Most tsunamis arrive within 20 minutes after the earthquake and run up to at least 20 meters. The Indonesian government has now adopted the 20-20-20 principle for communicating self-evacuation as the primary approach now for tsunami evacuation. Although they already had posted signs throughout the country for where to evacuate, the when and how fast and how high was not communicated. But now it is, because the 20-20-20 signs have been added to these already existing signs. The 20-20-20 principle also informs and encourages tsunami evacuation drills, which may be the most effective and definitely the most enjoyable ways to develop response efficacy. And it's interesting because, like the Gandhi marches, the group ends up being several times larger than when we started. And now evacuation drills are happening throughout Indonesia thanks to the support of GWB. I will close with this slightly altered quote by Ben Franklin, that an ounce of disaster prevention is worth many times more than tons of disaster relief. The humanity of mitigation aims to increase the self-efficacy of people in hazard-prone environments, to demonstrate that they have the resources, organization, and practices to withstand the worst effects of natural hazards. Thank you.